Hi, I'm Nevin, and I'm going to show you SpriteKit, which is my favorite addition to iOS 7. It's a built-in game toolkit written by Apple, built into iOS 7, which I guess everyone's going to use for 2D games from now on. It's basically Cocos 2D, but with much better API. So let's start out. I'm going to create a game called Orbivoid because we're going to avoid orbs. Here we go. So before we start out, let's look at what we actually have from the beginning. We have the app delegate, which is basically empty. We have a view controller, which doesn't have much. And it contains an SK view. What's an SK view? It's basically just a container for a scene. So what's a scene? A scene is basically the SpriteKit equivalent of a view controller. It contains the logic that you're using. It's setting up the scene, it's updating the game every frame, and so on. So we start out by creating a my scene, which is the scene that was created by default, and we present it on the view. So that's all we're going to do in here. Just take a look at my scene. It sets up a node. So what's a node? Well, SpriteKit has 4 primitives that are important. It has a scene graph with nodes. It has actions, which is everything that happens in your scene except 3 physics. Physics is its own category. So we got nodes, actions, and physics, and then the 4th is emitter nodes, which is particle effects. That's just another kind of node, but they are neat enough that I'm going to go through them as a separate item. So I said scene graph and nodes. What the heck is that? Well, if you've ever used UIKit, you know what a view hierarchy is. You have your UI views, and they contain other UI views, and so on. So you have a tree structure of nodes, of views, sorry. And a scene graph is the same thing, except it has nodes instead of views. So let's just run this example project to see what it looks like. Here we're creating a label node, which is equivalent to a UI label. Just create it with a font, set the text, font size, position, add child, that's add subview, but for SpriteKit. And then we have a touches began, same as UIKit, where for every touch, we create a sprite node, which is basically a UI image view with an image named. So this is very familiar. Set a position to the point where we touched, and then we're doing some action stuff that we're going to look at later. So when I tap the screen, I'm adding the image view. It's rotating, and we're going to look at why soon. And we can just tap, and we're adding these views to the screen. We have the label node, and now we have these 3 sprite nodes in our scene. It's not very pretty, but at least we have a working scene up and running. Alright, so why are they rotating? Sorry, before that, I guess the big question is, why would you use this scene graph if you already have UIKit view hierarchies? Well, the big difference between core animation, which is the thing that backs UI views, and SpriteKit is that SpriteKit updates every frame. It redraws the whole screen every frame, which is what you're doing in games anyway, because everything is moving around, the camera is moving around, so it's a very dynamic scene. While UIKit and core animation is optimized for changing as little as possible on the screen, which is true for most normal user interfaces, but rarely true in games. So that's the big difference between the two, and why you can't use the same one from the other. Alright, so now that we know the difference, let's look at one of these things that update every frame. It's obviously rotating here. So what you would do in some other game framework is to every frame update the rotation of your spaceship, but what we have here is instead an SK action with rotate by angle duration, which is how we want to update our view and how long it's supposed to take. And then we just run it. So it looks pretty similar to a CA animation, like a CA keyframe animation or something like that from core animation. But it's actually much more powerful than that because it's not just for animations. If we have a look at the SK action.h file in SpriteKit, which is one of my absolute favorite APIs right now, you can see that you have all these simple move, move by, move to, rotate, resize, scale, and other methods that change the location or appearance of the view. Also have fade, animate with textures. You can have a series of textures that you're animating through. Play sound file, colorize, follow path, and some other more complicated ones we're going to look at in a little bit. So I'm just going to show you the power of actions by using one of those more powerful actions called SK action sequence. So this is possible because every action has a duration, so it's natural to chain them. So we have SK action rotate by angle. We're going to rotate half a circle. It's going to take 1 second. SK action move by. We're going to move 100 pixels up. Takes 1 second. And once there, we're just going to wait for, say, half a second. And then we're going to SK action remove from parent. So that looks like this. I tap, it rotates, moves, sits there, and disappears. So without actions in some simpler game engine, we would have to keep track of these sprites, keep track of which state they are in, and have an update function called every frame and update their state and transition them to the next state and so on. But now we have basically a one-liner doing all this, and even removing it from the both from the scene and from memory with a single line here. But we don't need to update every frame yet, so we're going to remove that method. All right, let's do something more interesting. We're going to make a game, and it's going to contain orbs. We're going to have a player that's an orb. We're going to have enemies that are orbs that are chasing the player. First off, we're going to need an instance variable for that player. We're going to call it just player, and it's just an SK node. So just like in UIKit, where you have a UI view that contains other views that fill it up instead of subclassing UI view, we have a basic node here, and we're just going to replace this label with an empty node that contains a shape node. So this is basically a CA shape layer, but as a node that you can use in SpriteKit. Set it up with a path. It's going to be an oval in rect, and going to fill it. We're going to stroke it. It's going to have a nice glow, which is new, and we're going to set it up to the middle of the screen. That's not very interesting. We're also going to change this touch handler to move it around. So here we're just saying player run action. So instead of teleporting the player to the new position, we're going to use an action to interpolate it to the new position. It's going to be very quick, but at least it's not moving instantaneously. So with those two pieces in place, we have a circle we can move around the screen at a nice 60 frames per second. Well, it's not really that complicated yet. Alright, next part. This is an incredibly boring circle. We need particle effects. Every game gets better with particle effects. The really cool part about particle effects in SpriteKit is that they have a particle editor inside Xcode. So we just create a new resource, which is a SpriteKit particle file, and we're going to make a trail, and we're going to base it on the base it on the template called Spark because I like it. And I'm gonna call it trail and just put it into our project. We get this Spark image that is the basis for the animation. You can't really see it. Oh, there we go. It's just a blob, white blob. This is what it looks like right now. This is way too much. So I'm gonna sheet and look at the existing one. We can pull down the birth rate. We just need a few particles. It's going everywhere. We don't want the particles to have any speed, so it's just gonna, they just spawn and they sit there. Now we have gravity, so no, it's not actually gravity. We don't want them to fall, so we remove the acceleration downwards, and they're just sitting there. And we don't want this line, we want a circle, so we do this. That's a cool circle. It's a little bit too small, so we scale it up. 0.6 maybe, that's pretty cool. There we go, that's a pretty cool particle. I'm gonna change the color to something like purple. I like purple, something like this maybe. And it's still not quite right. What am I missing? Birth rate, lifetime. Yeah, we need them to live a bit longer. Don't want any speed. Oh yeah, we actually do want some speed. They're gonna wobble around. That looks really cool. Now when we move around, they have this really cool trail. Yeah, there we go. A little bit bigger maybe. Alright, so now we have this really cool particle. How do we load this into our project? Well, Apple made these SKS files be normal NS coding archives. So in theory, they're very easy to add, but they would be even easier if there was an emitter named method on skEmitter node. So this is just going to be a very simple helper method that uses NSKeyed on archiver to unarchive the object found in the bundle at the resource path that you send in. So once we have all this set up, we're going to remove the ugly circle and replace it with a trail. So we're just going to load trail.sks. I'm going to set it to the middle of the player and add it to the player node. It's going to look like this. It's going to be awesome. Yeah. No, this is not so awesome. So all the particles are added to the player. So when you're moving the player, all the particles follow with it. We actually want the particles to stay in the scene. So we can actually do that by telling the trail to target self for all the particles. So now that we move around the player, the particles are going to stay in the parent node, and it's going to look awesome. Alright, that's really nice. I want to pull down the... this is a bit slow. I'm not sure why it's... if the birth rate or something. Well, it'll have to do. Good enough. Alright, what's next? Enemies. This is just a lone player. This is not a game. We need enemies. So we're going to need a list of enemies. We're going to have multiple of them. Let's make an array of enemies, and then I'm going to make the enemy spawn about 1 second after the game starts. And it's going to be a node just like the player node. It's going to be just a plain node with an emitter node in it, which is this trail. I'm going to change the scales, they're a bit smaller. And I'm going to add the trail to the enemy, and then add the enemy to both the list of enemies and the scene. And then I want to run an action that is wait for 5 seconds and then spawn another enemy, so it gets progressively harder. So what does that look like? Wait a second, and just a pretty cool node. Nothing happens. We don't have any physics collision or anything, so definitely not a game yet. I do wish we had a sound though. I really like sound, so I'm just going to pull in this spawn.wave file. And playing sounds is so easy. It's just an SKAction play sound file named, and you just run it on any node and it's just going to run. And you can make them a part of these sequences too, but we're not going to do that now. Alright, so we're spawning enemies, playing sound. What's next? Well, stuff is going to have to move. We don't want to move them one at a time. We don't want to move them in like an update function every frame and try to make them move realistically. We have a physics engine, let's use it. So how do we do that? Well, on our enemies, we're going to have to give them a body. Here we have a physics body for our enemy. So every node, any node in SpriteKit can have a physics body. That's the physical representation of it. It won't show. It's not visible. It's only used for the physics simulation. And if we have a look at the physics body header file, we see we have a lot of them. We can make a circle, a rectangle, a polygon, a line, a series of lines, so a path, an edge loop. Especially an edge loop from rect is great to circle a game area, so you can move things outside of the area. But a physics body is not just the shape, it's also all the physical properties of the node. It's whether it's resting, what friction it has, damping, density, mass, area. But it's also the velocity, and it's also the object which you apply forces to and then apply impulses to. We're going to get to that later. So now that we have physics on it, let's see what that looks like. Here we go. Spawn and it just disappears. Where did it go? Well, all Scene_Kit worlds have by default gravity enabled. We don't want that for this game. So how do we disable that? Well, nodes have bodies, but scenes also have worlds. A physics world is the global environment which in the physics simulation is run. So we can just disable gravity on the scene's physics world and it's not going to move around. We're going to spawn the enemy here, it's just going to stick. Same as before, we don't have any collision because the player doesn't have a body, so they can't collide. Alright, I think the next step would be for enemies to be able to move around. They are going to move around by getting a force that points towards the player. So we're pushing them towards the player every frame. So we have this update method. We saw it before, and now finally, after doing so much, we've reached a location where we actually need to do something every frame. And so we have this method that does this for us. So in this method, we get the player position. We go through our enemies. And then we create a vector. Wait, what's a vector? A vector is a new type in core graphics. So you've seen CG point, CG size, and so on. Well, we also have a vector, which is a difference in x and y. Well, a point is a position in x and y, so there is a difference. However, Apple did not provide any methods for manipulating vectors, so I've had to make some for myself, and we're going to add them to the project. And they're basic vector stuff like scalar multiplication, taking the difference between 2 points and making a vector, getting the length, making a unit vector from another vector, and so on. So we're just going to import CG vector. And now we can get a difference between 2 points. So it's a little vector between 2 points. We're going to normalize it to a standard size, and then we're going to multiply it with force. They're always moving with an acceleration of 4 units per second square. And then we're applying a force. We're applying that force to our enemy node. What does that mean? Well, with physics body, we have both apply force and apply impulse, and it's important to understand the difference. A force is something that's applied every frame. For example, if you have an engine and something, it has its own means of locomotion, so it's moving for some reason. An impulse is something that you add once, and the physics engine is going to make sure that it's moving correctly. So if you push something, you shove it once, it's going to be an impulse, while if you're bicycling, it's going to be a force. Alright, so we have this. What does this look like? Yay, our enemy is moving towards our player. The enemy looks very similar to the player. I want to give them a cooler look. So the trail, I'm going to have a mess with the trail. And we can just set the color of the particle effect because of the way the editor works. The editor sets up an advanced like particles color sequence, which is a sequence of colors that are assigned to the trail with a timing difference between each color. So we're just going to set something that I think looks pretty cool. There we go. That looks really menacing. Good enemy. You're noticing that our frame rate is really bad. We're down to 20 frames per second. It's not usually that bad. But the simulator has only software accelerated, that is non-accelerated 3D graphics. So it's going to be really slow in the simulator, even though it runs great on device. You see these particles are, these enemies are moving really weirdly. That's because they have a rotation since they collided with each other. We're going to want to disable the rotation. There we go. Alright, what's next? Well, alright, so the enemies can collide with each other. We're gonna want to collide with the player so we can lose. We need to have a losing condition or a winning condition, either one, for it to be a game. So we're gonna add what's called a category, a collision category. So the way we can tell the physics engine that two objects relate to each other in a special way through physics is by assigning a collision category bitmask. And if you don't know what a bitmask is, I can just show you very quickly the programming calculator built into macOS. That a int, that is a normal 32-bit integer, is composed of 32 individual bits, and we can flip these individual bits, and those represent different numbers. But when we're talking about bit masks, we don't really care about the actual value, but only which bits we have set in the value. So we're saying that for player, we want to set the bit number 1, so that's going to be a 2. And for the enemy, we're going to set that bit instead. And this way, it's a fairly flexible, if low-level way of setting up things that can interact. I don't really have a good description. Well, anyway, so we're going to set up we have these two categories, and we're going to set up that we say that we have players and we have enemies, and we want the physics engine to tell us when a player collides with an enemy, but we don't really care about enemies colliding with each other and so on. So first off, the player needs to be collidable at all. So we're going to have to give it a physics body. And just like with the enemy, it's just a body with a circle of radius 10. It's slightly bigger. It has a mass, so it's not pushed around. Then this is the interesting part. We set a category bitmask. We tell it that this physics body is of the category player. And we want the physics engine to tell us when there is a contact, that is a collision, with an enemy. And of course we're going to have to set up the enemy body. Where do we spawn the enemy? Here we go. We're going to have to set that up to have the physics body to have a category bitmask of collision enemy. So now theoretically the physics engine could tell us about collisions. We're not quite done though. Oh, sorry, I'm gonna have to rename this class so that all my snippets work. Find and replace, it's gonna be orb game scene instead. Replace, don't want snapshots. The refactor function is broken in Xcode 5. That's why I'm doing it manually. Alright, there we go. So, how do we do that? Well, the physics world has what's called a contact delegate. It's basically just a protocol for being told when two interesting objects collide. And we're going to implement this method called didBeginContact, which is when two bodies start touching each other. And that's this one. Let's just smash the delegate in. Oh, sorry, that's the wrong one. So it's called didBeginContact. We're later going to have an instance variable called dead. So if the player is dead, we're not going to collide with it. Else we're going to die from some enemy. And after that, I'm not really interested in moving the enemy anymore. So I'm going to remove the physics body from the enemy once it has killed the player. So let's just add that bool dead and implement this die from method. I'm going to place it, I don't know, here somewhere. This is good. Die. So what does it do? Well, we're dead. We're going to steal a nice explosion from this project. This is what it looks like. It's just another particle effect. I just love particle effects. There we go. So we're going to make this particle effect called explosion. And I'm going to explode at the player's position. And then we're going to tell the explosion to run a sequence. It's going to be play this kaboom sound. I'm going to hear it because I have headphones, because I need this microphone. We're going to wait until the screen is full of particles so that they cover the things we're removing. And here you can really see the power of custom actions. You can just make an action that is run some code. And I'm just going to remove these two nodes from the scene. I'm going to wait a little longer for there to be some more particles, and then we're going to set the birth rate of the explosion particle emitter to be 0. Sorry. Which means it's not creating any more particles. But we're not going to remove the whole particle emitter yet, because then all of it is just going to disappear at once. Wait a little bit and then do nothing, because we don't have anything to happen when the game ends. But this is good enough. I think we can die in the game now. Let's see, it's so laggy. And collision. And now we can do anything. Alright, well, it's good enough. I would like for there to something to happen, so I'm going to create a menu scene. Let's see, we have a menu scene. I'm just going to steal it. It has a nice background. I'm going to pull it into this project. There we go. This is extremely basic. It's just creating a nice background particle effect, a title, a tap to play sort of indicator telling you what to do. And then here's the interesting part. When touches end, it's going to create this new scene, which is the game scene, and it's going to tell the view to replace the current scene with the game. And it's going to do it with a transition. So this is pretty similar to, I don't know, I guess a modal view controller presentation, except it actually replaces the old one. So if you want to have hierarchies of this, you're going to have to set that up yourself. SpriteKit comes with some really nice transitions built in. There's a crossfade, there's a flip, reveal, move, push, And I like this door open and close one. And then there's also the doorway, which is the 3D doorway you've probably seen in many other Apple products. Alright, so, well, we want the game to begin at the menu. So we're going to change the menu, the view controller to use this menu scene. There we go. And we want the game scene to switch to the menu scene once the player dies. So we're going to do import or menu scene. And so after the player has died horribly and there's been 1.2 seconds of silent contemplation over what the life meant for the player, we're going to run a block which creates an entire new scene, which is the menu scene, and presents it with the doors closed horizontal with duration transition. This is going to be awesome. You're going to love it. Here's our menu. And we tap to play immediately, and we transition back to the menu. This is almost a complete game. We only need one more thing. We need a reason to play the game. We need a score. So I'm going to add a score label. And I'm just going to count the number of enemies that have spawned. That's a pretty good score. So it's just another label node. I'm making it really big in the middle of the screen and setting it to the number of spawned enemies. Run. It's going to be glorious. Here we go. 1. I have 1 point. And the thing is, it's basically impossible to stop playing this game because particle effects are awesome and physics is awesome. I'm obviously not that awesome. 3. I need to play again. This took 31 minutes to build and it's already addicting, so yeah. I'm just gonna add some in-app purchase and then I am rich. 4. New high score. I guess I need online. 5. Well, you know, good enough. That's a basic introduction to SpriteKit. A more advanced version of this game is available on GitHub somewhere. On github.com/nevin/Orbivoid. And I'm Nevin, same handle on Twitter and all other places where you can search for names. Thank you for watching. I hope you liked it. Bye.